Hello, welcome to the first proper episode of the Strange Stack YouTube channel. Today's topic is wording through intuitive thinking. So, I'm going to start with this rather than anything related to computing directly because I think this is a very important topic to begin with, which has to do with how do you learn new things, how do you find new facts. Um, so, This whole thing was sort of inspired by a friend called Paz who had a problem a while ago when he decided to learn electromagnetism and couldn't do it. So the entire podcast or whatever this thing is that I'm doing kind of got inspired by that. Um, and I think what happened was he went to Wikipedia and started reading the definition of electromagnetism and not understanding it, of course, and clicking all the links and finding then the definitions of various things kind of just referenced each other, and he couldn't make heads or tails of it. And what I think is happening there, because I guess to a lot of you it's not going to be surprising that Wikipedia is a really terrible place to learn new things. What it is that Wikipedia is giving you sort of a surface definition of something versus deep understanding. It's like trying to understand what how a car works by reading about a description of a car, right? So somebody tells you like a car is a vehicle, it has four wheels, you drive it on a road. That doesn't really tell you much about how a car works, right? Somebody might tell, oh, it has an engine that moves it. Uh, you don't know how a car works. You don't know how to actually drive one. You don't know how to build one. You don't know how to fix one. There's a lot of stuff missing from just understanding the surface definition of something. Uh, and in order to gain deep understanding of a topic, uh, one you're going to need a lot of tools, and one of the tools is called intuitive thinking. Uh, and at least in my case, that's the first tool I reach to, right? When people say everything looks like a nail if you have a hammer, well, intuitive thinking is sort of my hammer. That's the source of most of my power and abilities as a professional. So I'm going to try and explain it in this episode and see if I can sort of give you at least a basic idea of what it is and how you can practice it a bit more. So the next time you decide to dive into a really deep and broad topic like electromagnetism, you're going to have at least some kind of a tool to tackle it with because it is a big topic and it's not exactly a simple one. So that's basically the plan. So let's start with the thinking process. This is the thinking part of intuitive thinking, and it's concerned with what is true. It's concerned with logic. Is this really true? Is this false? That sort of thing. It is a internal process where you use logic and language-based reasoning to determine if something makes sense. Uh, Not if something is sort of valuable or good or bad or whatever, just or useful or anything like that. It just concerned with, is this true? Is this consistent with what I already know about how the world works? And does it fit logically in my understanding of reality? So a good way to practice this skill is, logic and mathematical puzzles and games and stuff like that, like chess. Math especially is a very useful skill. You don't need to do advanced math, just basic simple math works. Just start doing some very basic like third, fourth grade math proofs, stuff like that. Learn how to do mathematical proofs. This is what we know. From it, such and such follows. Therefore, the triangle has equal sides or whatever it is. That sort of skill is crucial, and that's the foundation, right? This is how we judge if something is true or not logically. So um, you can use this skill for a lot of things, but that's basically its purpose. it is concerned with what is true. And if we're going to be diving into a complicated topic, that's going to be a crucial skill, because first of all, there's a lot of junk out there. Second of all, even Wikipedia is wrong sometimes. I know that's hard to believe, but it's fucking true. Oftentimes there are mistakes or deliberate disinformation sometimes. So logically thinking about what is true or not is crucial. Is it consistent? So this is the thinking process. In my case, that's sort of my main thing. In terms of the first thing I try to do is, okay, does this make sense? What is this when I try to figure something out? It's pretty effortless for me to start thinking that way. For some people, it's very difficult to start doing that. They approach the world differently. So the logical thinking part is still there in their brain, but they haven't developed it for whatever reason, or it takes them a lot of effort. But I'm basically here to tell you, if you practice it, it's gonna get easier and you're going to get better at it. So keep practicing, play around with it. You don't need to do the really advanced stuff, just the very basic stuff is going to sort of stretch that muscle. And it is a skill, so you're going to get better at it with time. So keep that in mind and don't get discouraged. If you find something difficult, go back to something simpler. And when you feel confident at the simple stuff, then push yourself towards the more complicated things. In terms of just abstract logic and stuff like that, just practice it in the abstract. Mathematics and puzzle games and stuff like that is a really good way to do that. Chess as well. So the next part of the process is intuition. Okay, what is that? So this has to do with asking what if questions. What is possible? It's about developing your own curiosity, generating new theories, and evaluating possibilities. Right? It's about reaching into the world and taking in all the possible things, right? There's an infinite number of things that could be true, that might be true, that are maybe true, but we don't know if they're true or not. But it doesn't matter. Right now, we're just trying to get a sense of what is possible, how do things work, asking questions, right? Daydreaming, thought experiments. Famously, Albert Einstein did this with imagining himself riding a beam of light. Of course, that's something impossible, but through the power of imagination, remember we talked about that last time in episode 0, we can sort of imagine these impossible scenarios and sort of gain a little bit of insight into what might be going on. Get a bit of an idea, okay, how does light behave really? And the way you can do that is through imagination. And this is the sort of the skill, the second part of the skill you're going to need for this. And of course, this is a bit more difficult than the other one, right? The other one is just, pick up a third grade math textbook and start doing it. Just practice. This one is a bit more murky. It requires creativity, but again, if you keep doing it, you are going to get better at it. So just try to come up with exercises for sparking your imagination. Think whatever ridiculous questions coming into your mind, right? What if the moon really was made out of cheese? What would that look like? What would actually happen to the cheese, right? Cheese behaves differently than rock. What would happen to the moon if it had the consistency of Swiss cheese, right? Ask stupid, ridiculous questions like that in your head. Like, maybe ask your friends, but mostly do it in your head because you don't want to embarrass yourself too badly. Or maybe you don't care, whatever. Just ask these ridiculous questions, these what-if scenarios. Think about history, right? What if Napoleon was never born? What would history be like? Just do these interesting what-if scenarios, or think about possibilities, right? What if time travel was really possible? What would the world look like in that case, right? It's about generating new theories, about generating new ideas about what might be happening. In the case of electromagnetism, you would be doing that constantly as you're trying to learn. You would be trying to imagine the implications of every new fact you learn about electromagnetism. When you learn that, for example, electricity flowing through a conductor is generating a magnetic field. You learn that fact. Okay, but what about in reverse? Can a magnet generate electric current if you put it somewhere near a conductor? Turns out, yes, that's how turbines work, right? Power generation. You spin a turbine, the turbine has a magnet in it, there's a conductor in it, and generates electricity. And of course, you have an electric motor, you put current through it. The current goes through the coil, it generates a magnetic field, and it interacts with the magnets in the electromotor, and it makes it spin. Same thing, but in reverse, right? So if you know one thing, you can kind of imagine the other one, because you ask yourself, okay, what if this happened in reverse? So there's all sorts of possibilities that you can sort of imagine in different situations, in different sort of, when you're giving a new fact about something, you can kind of imagine some implication. And of course, then once you have that implication, you have that new theory. Okay, what if we did the magnet thing in reverse? Then you have, of course, the combination, right? The loop. You generate new ideas, you verify them with thinking, and now you have a new fact. Whether it's true or whether it's false doesn't matter. Now you have a new fact. This is false, this is true. And then you can use that to generate new implications, right? Okay, it turns out it's true. You can do from magnetism to electricity and back and forth. What are the implications of that, right? You have a new fact, but now you have a new possibility for new theories. And you can keep doing that. Just coming up with new ideas, finding new facts. Those feed into the generation of new ideas. And of course, as you keep doing that, you're going to start getting better at asking better questions, right? You start with stupid questions like, what if the moon is made out of cheese? But then you get at better questions that are more focused, that are more likely to be true, or more easy to be verified, or make more sense, or are just more surprising, right? When Einstein sort of asked, okay, what happens when a beam of light travels at the speed of light? What happens if you're moving at the speed of light and then you shine a flashlight, right? Does the light from the flashlight go double the speed of light? No, it doesn't. So obviously that seems like a silly question. What happens to that beam of light? But turns out that's crucial, because it allowed him to realize that actually time works differently, right? The speed is the same, but time works differently. So that's how basically he got to it, through daydreaming and thinking logically through his daydreams. And of course, as you get better at asking better questions, when you're trying to verify them with logic, you're going to get better at answering them or verifying the answers. That's basically how sort of this sort of situation works. And this skill isn't just about learning stuff from Wikipedia, right? Because if you're, for example, a software engineer, or you're trying to fix your motorcycle, like there's a similar process described in the Zen and Yatra motorcycle maintenance, where he's talking about how to fix a motorcycle. This is the process by which you can fix a motorcycle. So it's an incredibly practical skill, right? You come up with an idea. Why is the motorcycle not working? And then you come up with an idea. Or maybe it's this. And then you test it. Okay, it's not that. Let's see if it's that other thing. And then you test that. Okay, it might be that. Okay, then just logically, consistently, step by step, getting better at all of these processes. And it's going to be very practical for anything. It might be anything where you're bound by the rules of reality in some way, right? Even creatively, right? When you're writing a song, you might come up with some idea and then you try to figure out, okay, does this musical idea kind of sound good, or is it interesting? Maybe you don't evaluate it with thinking, but you still use intuition to do it, to generate the idea. But maybe you evaluate it differently. Maybe it just sounds good or not, rather than using logic. But you can still use intuition for it. Or maybe you're just using logic in a different context, right? Maybe somebody asked you a question, somebody else. You didn't come up with a question, but then you used logic to answer it. So you can use these parts of the skill by themselves, or in combination with each other, or in combination with other things, in order to effectively have better ideas, or think clearly, or learn new things, or answer difficult questions and be sure that you're right, or at least less unsure, because you can always be wrong, you can always make a mistake. But the good thing about making mistakes is that also gives you new data. So now you know that something isn't the way you thought it was. So that's basically it, right? Thank you for watching. Follow me on Twitter, it's StrangeStack. Subscribe to the channel if you like. I hope to have a Patreon at some point. I have one set up, but I haven't done anything with it properly yet. I'm waiting for some content to be generated. And yeah, that's basically it. Hope you guys liked it. Eventually, I'm going to get to some hands-on, writing software maybe on this channel, or diving into some topic. Maybe we'll actually look at electromagnetism in detail someday. But before I get there, I kind of want to explain these sort of soft mental tools that you're going to need first if you don't have them well developed, before we can dive into the difficult topics. So I'm going to start you guys slow and then move on from there. So thank you again. Follow, subscribe, whatever. Have a great day. Have a great summer. Summer's coming very soon. Good day.